Life was good as a Unity indie dev, and then one day a drop error came in. Unloaded, and we were in a heap of problems. We had .ccs, what is it? Should I use it? 3 render pipelines. Things were getting deprecated without replacements. Package manager, loads of packages, another input system. We got poor documentation suddenly, multiple UI systems, which to choose. What are the game services? Why are my projects huge? What's the job system? And why is everything stuck in preview? Life's not so simple anymore, but let's have a look at the state of Unity as we're approaching 2023. If you're about to try to make your first game in Unity, or deciding which engine to use, or maybe you're even coming back to Unity after a while away, or finally maybe you're stuck in a rut a little bit like I have been, well, this is the video for you. And it used to be so simple. There were game objects, mono behaviors, a single render pipeline, and an asset store. And everything was native within Unity. Everything was pretty stable and the documentation was excellent. All the properties, methods, well documented, descriptions on how it worked, a bit of a code snippet to get you started, and some pitfalls were outlined. Performance and graphics features weren't the best, but for the simplicity, it was well worth the price. So when did the shit hit the fan? Well, I'd say about 5 years ago, Unity 2017, they started deprecating things before there were replacements. One example is the procedural materials. It used to work really well inside of Unity. They deprecated it, hardly without any notice, and replaced it with a third-party plugin that's stuck in beta for years, and I don't even know if it's still out properly. Another example, the network code. Also retired in 2018 LTS, never came with a replacement until this year, 2022. I think around that time as well, Unity started to bring some more seasoned developers in to solve some of the long-term problems. For example, the new input system that were introduced back then, it solved a lot of complex problems, making it more versatile for use, but it came at the cost of complexity as well. It was much more difficult to implement especially for beginners. And then we have DOTS and ECS. That's data-oriented technology stack and the entity component system. That started to be developed to solve some of the problems that Unity had with the performance. It couldn't perform on par with game engines like Unreal Engine, for example. And to bring it up to speed and compete with those, they needed to change the architecture a lot. But again, that comes at the cost of making it a lot more difficult for people to understand. And most of those people probably don't need the performance that it offers. And then we have the render pipelines. It used to be simple. A single render pipeline, the built-in one, you didn't even have to care about it. And then another two came along, one high-definition render pipeline, and then the universal render pipeline. That used to be called the lightweight render pipeline. We also used to just have the asset store to get third-party assets, either for free or paid ones. On top of that came the package manager, and that allows you to install packages which are free, either published by Unity or third-party ones, but again, it made it a little bit more complex. Which package to use, which one's still stuck in preview, which one should I have, which one should I use, which one is built in, should I use this package instead? Very confusing. Let's have a look at that as well. And then another thing that's been plaguing Unity for a long while is that a lot of stuff has been stuck in preview for a very long time. Again, DOTS is a very good example of that. It's come a long time ago. You started to be able to fiddle around with it, play around with it, but it's been stuck in preview, taken in and out even of existence in terms of you can't even access it through the preview package anymore. It's been hid away a little bit further. So it's difficult to know. And Unity usually promotes that you should use them to leverage and learn what they have to offer, but they also discourage you from using them in a ready game. And then what happened with the documentation? That used to be the best thing. I remember in Unite 2018 in Berlin, I listened to a talk by two ladies that were working for Unity, and they were promoting how well everything was working with the documentation. They were basically on the developers day and night to say, hey, this needs fixing, this is not clear enough. And that showed, their work really showed, because it was top-notch, the documentation. If you compare it even to other big giants like Microsoft, I struggled to read through their documentations because it's so technical. In Unity, it had a good description in the scripting reference. What did the stuff do? And then it had all the different properties, and the methods were clearly declarated so you could see exactly what they were doing. And then usually there was a really good code snippet as well and links to the other related commands. But in recent times, I feel like the quality of the documentation is starting to slip. If you look at the new Unity transport, for example, for networking, then that's been moved to a separate site. I'm not sure why that is. And it's not as well documented, and it's using totally different formatting. A lot of the scaffolding is there and the method names, but there are no code snippets and no real explanations of what the things do. And I hope that improves over time. All right, then we might ask, why did this happen? And I think about 5 years ago, one of the reasons was that Unity was going to become a publicly traded company. So they needed to raise interest in themselves, make themselves more attractive, I think, to the market for investors, and make sure that the stock did well. And that comes with a lot of stuff that you need to promote, that you're acquiring companies, you're building new features, you're going to compete with the best engines, the latest graphics is coming, everything's going to be bigger, better, faster, and it's going to control the market. This is the thing. And unfortunately, a lot of the people that were using Unity as the game engine were the really small studios, the solo devs, the small development teams. And I think they were left a little bit in the dust with all of this stuff that was being built for the market. And then the complexity, I think, come when you employ people that have a lot of experience in developing stuff. They solve the problems in elegant ways and probably much more efficient and flexible and dynamic and reusable. But again, that makes it more difficult for real beginners to learn. And then we have this competition with the AAA titles. And again, I don't think really that's what Unity should be chasing. It's cool that you've got really the performance of the dots and the ECS, but you're putting so much time and effort into the render pipeline, the high definition and the dots technology stacks and everything like that. And unfortunately, a lot of the majority of the developers that are not using those type of features get a little bit left behind, unfortunately. A lot of the features that maybe we would have liked to see the focus on, improving a lot of the tools for general game development, I think the time would have been better spent there. And then maybe like the high-performance engines like the C++-driven Unreal Engine, leave that market segment because you've got such a big other section of the market. So now let's have a look at the state of Unity. I've been developing Line War for quite some time now, and we've spent over 3 years, and for a very long time, we were stuck in Unity 2018 due to the networking issues. We've recently upgraded, and I haven't done much other side projects, and unfortunately, that's meant I haven't really kept up with everything that's been happening. So while I was researching to do this video, I started to look into everything. What's the state of it right now? The different things that I remember seeing in the past with the dots, the input system, the UI systems, the render pipelines. Let's have a look at those and let's do a flyover in this video. I want to do a quick overview, and then after that, I can start diving down into each different topic specifically. I was just editing this video and I went back to Unity's data-oriented technology stack or DOTS site just to make sure that I was saying the latest stuff. And it's a good thing I did because they just updated it. And it says DOTS is a combination of technologies and packages that delivers a data-oriented design approach to building games in Unity. Applying data-oriented design to a game's architecture empowers game creators to scale processing in a highly performant manner. DOTS really consists out of 3 different packages. The first one being ECS for Unity, Entity Component System. And it says it enables you to build more ambitious games. It's a data-oriented framework compatible with game objects, enabling seasoned Unity creators to achieve more thanks to an unprecedented level of control and determinism. Well, those are some flashy words, and there's a couple of things there that we really should be taken into serious consideration. The first one, it enables you to build more ambitious games. And to me, that means that if you want to squeeze a lot of performance out of Unity, get the latest tech, everything multi-processing, it's going to be bigger, better, then this could be for you. But if you're trying to make your first game, if you're trying to just get a game out to the market, if you've failed loads of prototypes, then you don't really need to go for an ambitious game. You should just get it out there and get it done. So ECS is not going to be for you yet. You should wait with it. Another thing it says it's enabling seasoned Unity creators to achieve more. So, okay, seasoned Unity creators, if you're new to Unity, if you haven't released anything with Unity yet, don't use ECS. That's what it says. In my mind, exactly that's what it says. An unprecedented level of control and determinism. Unprecedented level of control means that you're going to have a lot of things that you can tweak and fiddle around with. If you don't know what you want to do, if you don't need that, then you should avoid it. So let's put ECS on pause for now. Maybe we can come back to that when we've released a couple of games, Sale. Another thing I wanted to mention for the Entity Component System, and I think Unity's had a lot of flack for this, maybe a little bit more than they've actually deserved, because they've really spent some time on this paragraph here. They're really emphasizing on this. Unity powers a large majority of games on the market, many of which do not need ECS to be built. So we've got it here right on their website. Even though it's tempted to jump into new technology, it says here that many of which do not need ECS to be built. So unless you specifically need the performance, leave ECS until later on. That's what I'm going to do. And the second component here is the Burst compiler. And it says, Burst is a compiler that translates from IL/.NET bytecode to highly optimized native code. It uses the industry-proven LLVM compiler infrastructure to give game creators native code performance from C#. Burst also exposes CPU intrinsics. making it possible to fine-tune performance critical code. With Burst Compiler, you can actually pick certain parts of your code that you really need to boost the performance on, and then you can use the Burst Compiler on that. You will need to tweak the code a little bit and use native arrays and some other way of thinking, but when you get that in place, you can actually burst compile part and get it really highly performant. In LineWar, for example, we do map generations, and I'm looking at few of the parts of the map generator that has to run on the CPU. I'm looking at implementing those using the Burst Compiler, so I get more optimized code, because it has to iterate over a really tiny loop millions of times for each vertex and different type of pixels that it needs to sort out. And the Burst Compiler is really shining when it comes to those type of operations. Small, needs to operate in a really quick, tight loop, then that could be really useful. So I wouldn't recommend that you start with that, but if you notice somewhere in your game where it's CPU bound and you need more performance, then it could be good to look at the Burst Compiler to get like a little bit of extra speed out of there. And then we have the third component, and that is the C# job system. And it says, this system allows Unity developers to take advantage of multi-core computing platforms with parallelized code that can run safely and at speed. The C# job system exposes Unity's internal C++ job system, giving Unity creators the ability to run their scripts alongside Unity's internal processing. Okay, what does that mean? Unity really is single-threaded most of the time. So what that means is when your game is running and you enter a method of some sort, Unity is going to complete that method before it goes out and does something else. So if you want to do something in parallel, then the job system is a good way to do it. Another benefit of the job system is that it can run on multiple cores. So if you have 8 cores at your disposal, why not allow Unity to utilize all those cores and do something in there? You can get performance, and a good example again would be the procedural map generator in LineWar. It would be cool to get that parallelized across multiple cores, but in some cases, that's not necessarily what you want to do either. Because we're running the LineWar server on a Linux VM in the cloud, then we actually dedicate a single core to an instance, because we run 6 game instances on our single server. So you don't really want to spread out that operation across all the cores, because it would impact the other games. But if you're creating a game that can utilize all the cores, maybe you're doing some navigation stuff, or maybe you need to process a lot of stuff, well, then you can look at the C# job system and find particular parts of your code that could do with accelerating by running on multiple cores. If you're creating your first game, again, I've said this before, I would not really touch the C# job system yet either. Unless you specifically needs the performance, I would not use it yet. All right, folks, now let's have a look at the render pipelines. There are 3 to choose from, but let's make sense out of which one we should be using. We have the built-in render pipeline, the one we've always had, and then we've got the universal render pipeline and the high-definition render pipeline. And up until now, I've actually found it a little bit difficult to know myself which one to choose. I haven't been perfectly sure which render pipeline to choose myself lately, so I decided to deep dive into the different features and the cross comparisons between the 3 pipelines, and I started to pick out which features I actually thought would make a serious difference. So there's a whole bunch of different features where there's a bunch of yeses and nos, and these are the ones that I thought were particularly interested to pay attention to. First up is the wide asset store support. If you're planning to buy assets from the asset store, you might have to go for the built-in render pipeline, because there's not so many things that are compatible with URP and HDRP yet. That might change over time. If you're going to make a WebGL game or a mobile game for Android or iOS or the Nintendo Switch, for example, then you cannot use the HDRP, so you should choose the built-in or the URP. If you're going to make a 2D game, again, do not choose the HDRP because it's not supported. You have to go with the built-in pipeline or URP. And to narrow it down a little bit further, you should pick the universal render pipeline if you want to have 2D lights and shadows. Simple choice. If you want screen space reflections, you're limited to the built-in render pipeline or the HDRP. You cannot have those in URP. As an example, I use screen space reflections in the menu screen of LineWar to get a little nice reflection. So I'm a bit sad to see that's not in URP, and it might be coming, but for now, it's not there. And then we have the VFX graph, which is a new type of particle system driven by GPU power. Very performant, but unfortunately it cannot interact with the world and physics. But if you want to use the VFX graph for nice visuals and millions of particle, then you cannot use the built-in render pipeline. You have to go for URP or HDRP. If you want physically based shading on your terrain, then you cannot go with a built-in pipeline. If you want decals, you cannot go with a built-in pipeline either, but they're both supported in URP and HDRP. As a substitute in the built-in pipeline, you can use something called projectors. I never really got the hang of those, and I'm looking forward to playing around with the decals more. Hopefully they're a bit easier to use. If you want to gain some performance by batching of shaders, you cannot pick the built-in render pipeline. but they're supported in both the URP and HDRP. Batching by shader means that you can have many materials that are sharing the same shader, yet they can have different properties applied to them, and they'll still get batched for additional performance. One of the limitations in the built-in render pipeline was that if you copied and instanced multiple versions of a shader or material, then that required some additional power, reducing your performance. There is built-in post-processing in the URP and the HDRP. In the built-in render pipeline, you have to install a separate package for the post-processing, and I always found that to be a little bit awkward to use, so I'm looking forward to actually having it built in the new render pipelines. And then we come to a few easy ones, because you have to use the HDRP if you want to go for ray tracing support, path tracing, volumetric clouds, or use things like the NVIDIA Deep Learning Super Sample, or DLSS. Well, theoretically, you could write your whole own scriptable pipeline too, but we're not comparing that right now. And here's a funny one. I didn't actually know this one myself, but since Unity 2021.2, you can use the shader graph in any pipeline. You did not used to be able to use that one in the built-in render pipeline to create your materials with the visual graph editor or the visual material node editor, but now that's supported in all of them. But if you want to use it in the built-in render pipeline, you have to install that as a separate package from the package manager. But still, cool that you can use it. And now I've actually made up my own mind. So by looking at the feature sets, I'm going to use URP for anything 2D that I do, because I get the bonus of the lights and shadows in the URP compared to the built-in render pipeline. I'm also going to use the universal render pipeline for any simpler type of game that I make, because I want to have the portability to mobile devices and the additional performance that it offers. And I want access to the VFX graph and also the built-in post-processing. And finally, I'm going to go for the HDRP if I'm going to make any fancier type of game that I'm going to target for console or PC. And even if most of my stuff is low poly, I'm still going to go for the HDRP if I target those platforms and I want those additional visual features. If I want additional quality on the shadows, volumetrics, and even ray tracing and reflections, I'm going to go for the HDRP in those cases, as long as I know that I don't want to compile it to a mobile. And then we come to the user interfaces, or the UI, and of course there are three to choose from in this case. First up, we've got the Unity UI, which is probably what most people are used to. It's a canvas with a bunch of UI elements on it, and you've sliced your sprites and created nice visual graphics for your UI, and then you hook those up with different actions and events in the inspector, and you connect that to events that are going to be triggered inside of mono behaviors. Maybe you want to close something, open a dialogue, or start a game. That's what most people are used to, but there's a new player in town, and that is the UI toolkit. And instead, it's a bit more like web programming, where in this case, you have UXML files and USS files. For UI toolkit, there is also a new UI builder, which is a new window where you can drag and drop components and design your interface. You won't have the ability to hook up events in the inspector like you did before, and in this case, everything has to be driven through C#. So if you want to have something that happens when you click on something, then it's going to be powered by C# in the background. It requires a little bit more programming. What I look forward to with the UI toolkit is the ability to apply new themes and modify the entire look of a game. It is a pain in the current Unity UI to do that. In line work, for example, if we want to change out all the different buttons or dialogues, then you have to start modifying prefabs, and it might break different actions that you've hooked up, and it's not really so straightforward. And in this new approach, with having a separated design from the code, it's going to make it a lot easier. If you're multiple people working on a game with version control, then the Unity UI is a bit of a pain too, because if you make any modifications to the UI, you're going to have merge issues when you check that code in at some point. That's going to be a beautiful thing in the UI toolkit, because then you can do whatever you want to the code and do whatever you want to design, and they won't really have any merge issues. So if you're going to make games with multiple people, it might be worth having an extra look at the UI toolkit for that. When I tested the UI toolkit, it felt a little bit foreign at first, but fonts and graphics rendered and scaled very nicely. And then I found that it looked a little bit different in the UI builder compared to the game, but that was because of the theme. It defaults to Active Editor theme, and I needed to change that to Unity Default Runtime, which feels a little bit strange to me, but I understand why now. It's because the UI toolkit was actually originally designed for editor extensions, but then the scope was extended to include runtime. What scared me a little bit more though is that I had some artifacts in borders between the elements in runtime, and I did not see those in the editor. And that scares me quite a bit though, because I don't find it acceptable to have any gaps or anything like that between my UI elements. They have to look pristine and perfect. And for me, the UI didn't scale as expected either, so I'm going to have to dive a little bit deeper into that in a separate video. And there's a third option as well, and that's been around for quite some time, and it's the Immediate Mode GUI, or imgui. And if you've written anything to trigger anything to be drawn from onGUI, the method inside of a mono behavior, then you've been using the immediate mode GUI, where you can actually create stuff on screen from within the script. You don't create anything offset. Let's have a look at what Unity recommends. Unity recommends Unity UI for runtime, that is games, especially if you need a UI in a 3D world, VFX with custom shaders for your UI, or easy referencing from mono behaviors. Unity recommends the UI toolkit for editor extensions, but it can also be used in runtime, especially in some cases, and that is if you need to produce a significant number of user interfaces, or if you require familiar workflows for artists and designers, and if you seek textureless UI rendering capabilities. When I was doing some Googling, I found that the UI toolkit was designed for the editor first to create editor extensions, but it was extended to cover runtime later on as well. That might explain why we had the different theme issues and it defaults to an editor theme instead of the runtime theme. So armed with this new knowledge now, I'm going to keep using the Unity UI for most of my simpler games, and I'm going to look again at the UI toolkit when the time is ready if I'm going to make more elaborate UI requiring games.
Okay, now let's move over to the Unity networking situation.
All right, folks, now let's move over to the Unity networking situation. And we used to have Unity networking, or UNET. That was deprecated in 2018, well, version 2018 that is. It's been 4 long years without a solid replacement, but now finally out of the woodworks, we've got a few replacements. And first of all, we're going to look at netcode for game objects, or netcode, and let's have a look what it says. It's a high-level networking library built for Unity, for you, to abstract networking logic. It enables you to send game objects and world data across networking session to multiple players at once. With netcode, you can focus on building your game instead of low-level protocols and networking frameworks, and the current version is 1.1.0. Personally, I haven't actually used this one yet, but it does sound like a pretty nice idea to be able to take game objects, compress them, optimize, and send it across the network on certain frequency intervals. So if you're going to make a simpler game where you want to just have players synchronizing maybe some objects, run around in the same world, maybe shoot some people down, well, I think this is going to be a pretty good solution for it. For the game that we're making, Line War, we cannot really use the netcode for that because we need a lot more control and specific type of serialization. And we have a separate package for that was also released earlier this year, and that is the Unity Transport package. Let's have a look at what it says. It's a low-level networking library geared towards multiplayer games development. It provides a connection-based abstraction layer over UDP sockets with optional functionality like reliability, ordering, and fragmentation. And in those words is why we actually need to use it, because we're taking a lot of our multiplayer units, we've got hundreds or even thousands of them, and we need to serialize them, send the data across on separate type of intervals, lerp them across the world, optimize that type of data. At the same time, we've got to record all of that into our replay format. We've got to send chunks of fog of war data across the network. So we need that extra control. So we've actually gone for the Unity Transport package. Our experience with it has been okay. I mean, we moved from UNET, and it's a new way of thinking. They're using a lot more struct and more native arrays and things, a little bit more treacherous grounds to walk. You can run into some memory leaks and stuff. But one of the main things that we ran into was the documentation issue. First of all, there's a whole new site to document these things. And I hope that's not the way things are going to be for all the packages, because it used to be so nice having all the documentation in one place. If packages are going to document themselves in separate sites using different formatting, we're going to struggle quite a lot. And here's an example of how terrible it is. We go to the documentation site, the main one, and it says that the latest version of Unity Transport is 1.3.0, and it refers us to the full documentation at the Unity multiplayer documentation site. Here it says that Transport is on version 1.0.0, and in the dropdown there is no sign of 1.3.0, only an unreleased 2.0.0 for the beta. Very confusing and unacceptable to me. But we're actually using Unity Transport now in production for Line War. Version 1.0.0 was released earlier this year on the 28th of March in 2022. It works, but it's pretty difficult to use, mostly because of the poor documentation. We had to look at some old release notes even to find some of the type of error messages and disconnect issues that we had. So we looked at release notes from beta versions or even pre-beta to be able to figure out what was going wrong, because it wasn't documented in the actual documentation site. We also had to dig through some of the source code that was in a Git repo for the package to be able to figure out what was going on. Not ideal, but it works. But I'm hoping that they're going to get to a point where they actually make the documentation a little bit nicer. Because it's on version 1.3.0 now. I was hoping that it would be updated, but it looks pretty much the same. But saying that, there is still some good parts about the documentation when you look at it, and you have to start to understand how the UDP packages work, how the reliable pipelines work, how you can be able to fragment packages like that. So unless that's what you're into and you don't need it, maybe you should go for a netcode or another third-party solution, and maybe leave the Unity transport unless you absolutely have to do it. We had no choice, really. We had to go for something like that. I should also mention that Unity have a few gaming services now available for multiplayer, and it comes with a few associated packages. First of all, we got game hosting provided by Multiplay, and I actually looked at that last year before we launched our own version of it, and I tried to contact them because you couldn't sign up for Multiplay, and I was meant to send an email, which I did, and I was meant to get contacted if we were interested enough. No one contacted us, so we had to build our own solution instead. But now that I'm looking at it, it seems like they've launched it and it's pretty nicely integrated, and we're doing it pretty much similar, funny enough, that the way they do it, but this is a nice abstraction layer where you can log into a portal, upload your server executable, and that will deploy it to a server for a Linux server or a Windows server, depending on what you want, and then you of course pay for that. I think we're going to end up saving a lot of money in the long run because we do all of that ourselves, and we've found a good cloud provider, and we can dynamically scale our servers up and down. But this Multiplay solution, the game hosting, is pretty much exactly the same, but it's built as a service. But then you're going to pay a little bit more for it, but it's probably worth it because it's taken us a lot of time, effort. We're doing a lot of API development, Linux scripting, bash scripts, booting up and down, monitoring it using APIs, querying it, seeing if we need to spin up new servers, shutting them down, and there's a lot of work. So maybe you should look at the Multiplay. You actually get 800 credits for free, which I looked at. You can spend about a month spinning up and down a few servers. So it's going to cost you a bit to run the multiplayer on this. So you could look into peer-to-peer networking instead if that's your preference. On top of the game server hosting, you have to find players to match against each other and put them in lobbies. And I see that Unity's got a few things for that too. And then we have the Unity's Matchmaker service. And it says that Matchmaker is part of Unity's growing suite of multiplayer services that are designed to help you create and operate multiplayer games no matter what engine you're using. Interesting. Ooh, another engine. So features: simple player assignment using queues, advanced player segmentation based on configurable filters, complete control over your matchmaking logic using the rule-based matchmaker, blah 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 blah. The reason why you'd want some sort of a matchmaking service, whether you create one on your own or use a service like this one, is that you want to have different type of criteria to match people together. For example, maybe it should be people of equal skills that play against each other, or maybe it should be in the same region if your game has lag issues. Maybe you want to apply some filters so they're playing the same mode. Maybe it's capture the flag or last man standing. And then you need lobbies, and there's a package and a service for that too. And a lobby is basically like a staging area for players where they can gather before a game starts. And once they're all ready, they've set the ready status, and then you connect to your game server. And this is a service, and by the looks of it, you get a lot of those features. It looks like it's got a few more features than Steam has got, because this one's got a built-in ready state, which Steam doesn't. We have to do that through some additional metadata. And then Unity offers a relay service, and you connect peer-to-peer players via this relay, and it comes with 50 concurrent users license for free, which is pretty cool. That might not sound like a lot, but believe me, 50 players concurrent in a multiplayer game is more than you think. That could probably translate to about 500, 5,000, at least 10,000 sold copies of your game, because a lot of players don't play at the same time. They have different days. They don't play at all. They try it out, they leave it on the shelf, they come back after a month or 3 days. So 50 concurrent users, you've probably sold over 10,000 copies of your game in that case. So that's actually a pretty good thing. You should go for that and don't complain too much about it. Relay is pretty nice as well, because you can have your players connect from their ones and across the relay to each other, so you don't have to do the NAT punch through. Definitely worth looking at this. We don't use this for Line War again. I keep saying this. It's because we're hosting our dedicated servers in Vultr we're using at the moment for Linux. But we spin up machines there. They're ready to serve. We've got one virtual machine serving 6 games at a time, and maybe you have 2 to 4 players or 6 connecting to that one. So we're all connecting across the network into the Vultr VMs. We don't really need the relay, but this is very good, because if you can get away with not having a server that you have to care for, pay bandwidth and make sure it's up and running, if you can do connectivity using the relay, basically like peer-to-peer, then you should do that if you can, if you're not too worried about cheating and if there's no performance issues. Then there's something called the Vivox and voice. Not too interested in that at the moment. Most people seem to be using Discord and speak outside on a side channel when they play anyway. So, but it seems like they've got something cool there as well. Okay, so my conclusion then is that Unity actually seemed to have gotten pretty good on track this year, 2022, with their different networking services. Both the Unity Transport Package, the netcode for game objects seem like they're out in production, they're working, which is great. The additional service now with multiplayer server hosting, we've got matchmaking, lobbies, and relay. It's there. You should probably give it a go now. If you want to make a multiplayer game, you should try it out. I think it'll work. But that brings me to my last tip about multiplayer games, which is don't make a multiplayer game. Believe me, you should wait with that. Unless you're really, really ready for it. If you haven't released any game at all, start with single player games, because there is a heap of things to care about when you create multiplayer games. It might not sound so complicated, but it is. First of all, when you develop it, you need to be able to test it. You've got different clients. You have to build some local clients. If you're doing like us, we have to connect it through Steam. You need multiple Steam accounts. You connect to a server. It takes a long time to build it and test it. And then once you've actually managed to get to the point where you can play across a network, then you need to find players when you launch it. And we had a successful Steam launch. We sold pretty good copies. We're on the top of the trending list on the main page of Steam for a good 10 days on the front page. And still, it's difficult to get enough of players that actually keeps it. After the initial 2 months or so, those numbers are going to start to dwindle. And unless you can pump new players to your game, people are going to get frustrated, angry. They're going to think that you owe them everything. They've paid $15 now for a game. They've only gotten to play 100 hours of it, and it's ridiculous that there aren't more players. If people would just buy the game instead, play it instead of complaining, it wouldn't be a problem. But that's not how the world works. If you're ready to make a multiplayer game, go for it. My tip is wait with it and add it maybe later for the game that you're making, or do it in another game next year or something. Well, there's always next day, isn't it? Next year. What did you lose?
My tooth.
Your tooth?
I want to swim.
You want to swim? Yesterday was 37 degrees. Today it's only 34. What is it? If you're going to make a game, keep your eye on the ball, progress forward. Don't get lured away by all the fancy tech and stuff like that. Just progress, use what you need. If there's a package for it, if there's a service for it, check it, use that one probably. It's faster, better than reinventing the wheel. If it doesn't cost too much, or if it's stuff in preview, then you shouldn't use it. But keep your eye on the ball, progress forward. Don't get lured by the fancy tech and make a game. And don't make it multiplayer now. Remember, do that later on, or add it. I don't know, version 2 or something. Woo, there's so many things to deep dive into from here. I'm going to look forward to doing that at some point, and there's so many things to look at. I'm very happy about that. The important thing is that we're going to see each other again. So come back to this video if you haven't come back to this video. So come back to this channel if you want to see some more. Hit the like button if you liked the video, subscribe if you haven't already, and thank you so much to my Patreons. You're making a huge dent in my pocket, I was going to say. In the right way, though. That sounds like a bulge in my pocket. That sounds even worse. So thanks to my patrons, patreon.com/Infancia. It's very valuable. And especially now that I've moved all the way down under here, I'm in a new house. Everything's feeling foreign. It's super hot outside. And I can do it with all the help that I can get. So thank you. I need aircon in this room. I've got a fan. I've got fans. I've got a fan. I need more. But I'm buying less now because I'm saving a lot of money instead. Remember in my last video, master game plan, don't get too many things. So again, contributions welcome. I'm going to feed my kids with it. So have a great life, and I'll see you next video. Take care for now, and bye for now.